Hey everybody, I'm Zach Peterson and I'm here today to talk to you about some of the best practices and guidelines for using sublayouts in your Flux projects. Sublayouts are an object that is unique to Flux. They essentially allow you to define a section of a PCB layout as a part. You can then toss it into your schematics or your PCB layout in a new project and wire them up to other components just like any other parts. Now make sure to follow some of these guidelines because they will help you get the most value out of your sub layouts and help speed up your design process. So hop onto Flux, follow along, and let's get started. Now, one of the things that you'll notice inside of Flux, if you bring up a sub layout, that you can put components on the single-sided placement or double-sided placement. So you can put them just on one layer, or you can put them on two layers. And if I just go here into the PCB, I can even take this particular sub layout, and if I wanted to, I could actually flip it to the back layer. So I can have sub layouts that are both placed with components on two layers or on the back layer, or I can just have a sub layout and just put that sub layout only on the back layer. I think it's important when you're first designing sub layout to consider where you're going to put those components. Single-sided placement might be advantageous because it leaves you some room to access all of those available connections in the sub layout through the back layer. All you would then need to do is ensure that there's just enough room for vias, or that you actually place the vias inside the sub layout. And so that's what's going to allow you to ensure that you can access any of those connections on the opposite layer just using the standard routing tools inside Flux. So make sure you think ahead a little bit and decide where you need to put components, either on a single side or on a double side. Now, one thing that I think is important when designing a sub layout is to place the connections that you'll need to make to other components somewhere around the edge of the sub layout region. So if we just connect maybe a resistor onto this sub layout symbol, then you can see what I mean. So right now I'm just going to add a resistor to two of the pins just to keep it simple, and we'll be able to see where those connections arise in the PCB layout. So once I place that resistor, move over to the PCB layout, you can see here that this resistor has to make two connections, right? One is actually on the outside or near the outside of the sub layout region, but the other is actually one of these pins coming directly off the integrated circuit. And so you can see that right here. Now this pin, in order to reach it, you're going to have to place a via over here by R1 and then route in here to the interior region of the sub layout. However, for this one, you could basically use this via right here and then place another via over here by R1 and then route in through the bottom layer. So this one right here, this connection, is going to be much easier to make to R1 than this connection over here at the edge of the integrated circuit. Now, just as a counter example, if we go over here to my list of submodules and search for this guy, we can see here we have an STM32 sub layout. And so I want to add this one in just to compare. So if we look at this particular sub layout, we move it off to the side here, you can actually see where all of the ports arise. They're actually right here along the edge. Literally everything is right along the edge of this sub layout. So this sub layout is going to be really easy to connect to other components that you're going to place into the design. So I think something else that's important to note about these sub layouts is that they've been designed for specific functions, and that's actually a really great way to design sub layouts. So if we go into this schematic, your sub layout 2 is to provide access to specific interfaces on a microcontroller. Now the microcontroller might do some other functions, but specifically this symbol is just to provide access to these ports coming off the microcontroller. Similarly, if you remember, this is a CH340 chip. So this is essentially just converting serial to USB. That's the entire function of this sub layout. So when we look at the sub layout functionally or designed functionally, it's going to be much easier to pick and choose which sub layouts you want to connect together to create your design. So always think about designing specific functions into a sub layout and choosing sub layouts based on function rather than just based on a part number. Now, the next thing that you'll notice on these sublayouts is that you have limited pin accessibility. So here we can access some of the pins on these sublayouts, but once we look inside the PCB layout, we see that there's actually a lot of pins that weren't exposed in these sublayouts. And so as a result, we can't use those pins to make connections. So I think it's a good idea when creating a sublayout to expose as many of these interfaces as possible. And what I mean by expose is to make sure that you can connect to these pins inside the schematic. So if we look in the original design file for this sublayout, we can actually see inside the schematic that there's quite a few connections that just weren't connected to a terminal. So we don't have access to them inside of the main project right here. If you wanted to provide access to these pins, you would then need to connect terminals to them and then update this inside of the schematic, and then it will update inside the PCB layout and you can get access to each of those pins. So right now the way this sublayout is designed is it's only going to allow access to this differential pair and then to the SCL and SDA pin on this microcontroller. So I think it's a great idea to expose as many of those interfaces as possible. That way this sublayout is going to have the maximum level of adaptability in your projects. And again, to do that is very simple. Just right click on the sublayout, go to open. It's going to open this window over here with your sublayout, and then you can start making modifications to this schematic and to this PCB layout. Those will update in this project, and then you don't have to worry about it. You can then just continue on designing with these new exposed interfaces. Now, I think the last piece of information that's really important about sublayouts is the description. I think it's very important to create a concise but complete description of the sublayout. That way, when you're viewing the sublayout in the search bar, it's going to be very clear what is in this particular sublayout. So here you can see that this just says the part number and then with passive components as a sublayout. So that's pretty good. I think a better approach would be to maybe update this to state specifically access to differential pairs and then SCL SDA. So if you can maybe update that so it's a little more complete, that's a good idea. USB to serial should be pretty clear what this particular sublayout does. Maybe you can update it a little further as far as the form factor, if it's 1 layer or 2 layer, whatever the case may be. So that's just something to think about in terms of cataloging all of these sublayouts. And then of course, if you make them publicly available, it's going to be much easier for somebody to find these sublayouts and understand what they do if they have a very nice complete description on them. Now inside of this sublayout, you might notice something very important, which is, if you zoom in, you'll see that there's a ghost wire here between these two traces. So this sublayout, or this particular sublayout, has not been fully routed. So make sure that you check for that. If you're going to be using a sublayout from somebody else's, or that somebody else has created, and you found it in the public library, just make sure to go in and review it first. It's important to review these just to make sure that everything was routed, there are no open connections, and that it's ready for you to use in your own project. Now, the last thing I want to mention about sublayouts is that the guidelines that we've provided here are not the only way to use sublayouts. You're free to experiment with sublayouts however you want. You're free to design them however you want. These are just tips to help you get the most value possible out of sublayouts and use them in such a way that they're very easy to mix and match and then connect together in your own project. So feel free to play around with the sublayout system in Flux, make them publicly available for other users, and of course play with other users' sublayouts. We hope that you've enjoyed this video, found it informative, and we'll have many more tutorials to come soon.